So hi, can you tell me about what it's about here?
So this one is about software synthesis, which is a technique to to automatically generate programs from high-level specification. So the idea is that you can try to run the specifications, and then internally this tool will try to automatically reason your specification and then try to generate software for you if there exists one, or if the specification is inconsistent, he will tell you how to fix it. So I would like to see a little bit about a very simple demo. What I can do is that I will open a case called stairway lighting. So you know that this is a stairway lighting, and then what we can do is that we have two buttons. One is, and then two lamps. And what we really want is that if someone press button 1 or button 2, the light should be on for say 10 seconds. So what we can do is that we can just try to select one of these templates. These templates are used as assistants because internally the tool operates on formal language. So what we have is these kind of templates that facilitates users to do the things. Of course, you can really do formal specification if you want. So remember what I have as specification is whenever button 1 or button 2 is pressed, what we want is to have lamp 1 and lamp 2 to be on, say, 10 seconds. Okay? So then what we can do is that we can try to press trigger synthesis engine that is able to create me PLC code, where I'm able to upload it, download it to the PLC, and then it is able to run. So this is roughly the big picture of software synthesis, where from specification to implementation in a press of a button. So we have been trying to apply this kind of technologies in various aspects. So what we are now currently interested in is this kind of concept of overlaying a neural network with a certifiable controller. So the idea is that if you see from here, this is actually a gamified traffic simulator for highway overtaking scenario. And what we want is that we want to have some sure guarantee that, for example, if the car is already in the rightmost lane, it is never possible for the neural network to suggest him to go to the right. So this is something that we want to check or to enforce. So what we can do is that we are able to synthesize a runtime monitor for this particular case based on the specification. So we can have again another example, the specification for this traffic example, where what we essentially want is that if the minimum distance to the front car is smaller than the safety distance, I should never accelerate. And similarly, if the minimum distance to the back car is less than safety distance, I should never decelerate. So what I can now do is I can also synthesize a controller for this setup. And then this is actually the code that you see from here, which is the same as here, where you actually have it over here. So you see the simulation result in this particular case, currently it is largely always safe. But if you try, we have also tried other examples that, for example, I can try to maybe load one net, and then it is sometimes possible that it gets some unsafe output. But it depends very much on the context. Okay, so that's roughly what this demo is all about. Thank you.
Thank you very much.